Hi, my name is Dan Lorenc, and I'm the founder and CEO of a supply chain security company named Chainguard. In today's HelpNet security video, I'm going to talk to you about Wolfi, the first community Linux undistribution built by default with supply chain security features in mind. So we'll start by discussing the problem that Wolfi is designed to solve. Over the last couple of years, there's been a massive push for software supply chain security. This takes the form of both integrity protections, vulnerability management, and transparency. And this push, both from the private sector and federal government, has left organizations struggling to secure their pipelines and manage vulnerabilities, especially when running in the cloud. Existing tooling and Linux distributions don't support supply chain security natively, so they require users to try to bolt on supply chain security features through things like signatures, software composition analysis, software provenance, and software bill of materials, or SBOMs. This is a result of how software used to be built and the changes that we're trying to make on pipelines to make them more secure. There's been a shift in how software is built today, especially with the push to containerize environments in the cloud. And so we're building Wolfi, a new Linux distribution, to try to take advantage of these changes and these new features. Today, there are roughly 1,000 Linux distributions in the world. A Linux distribution takes the form of a Linux kernel, right? You're distributing Linux, and then a whole bunch of other tools to make that kernel usable. This usually includes something like a package management system, and then a lot of other packages that form the user space, allowing you to interact with the system. These packages usually start from some upstream repository. Distributions aren't maintaining all of this stuff themselves. So they start with a bunch of these packages coming from upstream repositories, and then they modify them or tweak them to make them work inside of their distribution, or sometimes to carry security patches that haven't made it upstream yet to make the packages more secure or fix vulnerabilities that have recently been reported. But most of the workloads today are done with containers inside of cloud environments. And Linux distros were designed to be running on bare metal or virtual machines where a kernel is required. The shift here is that once you're running inside of a containerized environment, you don't actually need the Linux kernel anymore. That's provided by the host that your container is running on. So that provides an opportunity to design a new set of user space components for containerized environments that don't come with the kernel and are designed for immutable infrastructure and container rebuilds rather than patching and stateful systems. This means that if we take a couple steps back and design a new Linux distribution to meet that security gap and to take advantage of these new environments, we'll end up with something a lot more optimized for this new way of running software. If we design this for software supply chain security, integrity, and transparency, then we can get a whole bunch of awesome features out of the box, like accurate SBOMs or software bill of materials that are generated during the build process, not at the end through an SCA or software composition analysis tool that tries to reverse engineer or guess what's inside these compiled binaries. So to summarize, the rise of containers and the ability to release applications much faster in a holistic environment rather than patching things one at a time changes the way distributions can be designed, and they allow us to build a distribution that's designed for software supply chain security right out of the box. So we can dive a little bit deeper into why we're here and some of the problems that people are facing today when running Linux inside of containers. Over the last couple of years, containers have truly become ubiquitous in how developers build and ship software today. This is because of the rise of Docker, the Open Containers Initiative, and of course the Kubernetes platform. Containers have changed the game here a little bit by being immutable in nature. So instead of patching or applying changes to running containers across a fleet, people instead simply build new containers. Those new containers contain updates to their application, security fixes, or changes to how the application is supposed to be configured. By rolling these out as one atomic unit, we avoid a lot of the complexity dealt with pinning packages to specific versions, updating a single package without updating the others, freezing sets of them, downgrading stuff in place, and being able to do all of that safely in case there's an error. Instead, we just build a brand new container with a new set of all of our transitive dependencies and try rolling that out. If something goes wrong, then we stop that rollout and we still have the old container, which contains an entire snapshot of the old application, so rollbacks become easier and safer at the same time. Unfortunately, these benefits come with a few drawbacks or a few added areas of complexity. Containers package a lot more than just a typical application would. They package the entire distribution, an entire set of dependencies and packages. And they're built in a whole bunch of different stages. That means that a typical container image tends to lag behind the upstream updates. Right? If a distribution updates packages today, you don't get them automatically because you don't have an auto updating script running anymore. You first have to build a new base container image that contains your distro and any types of dependencies, and then rebuild your application container image. Sometimes these base images come from third parties or other communities, so there can be lag here in all the different steps between getting a patch upstreamed into something like OpenSSL and then getting that deployed to your fleet. This means that a lot of containers running in the wild today are full of known vulnerabilities. These vulnerabilities might not actually affect your running application, but you still have to look and triage and decide which ones are real, which ones are important, and which ones to prioritize fixes for. This creates a huge signal to noise problem where people can't actively and effectively triage these vulnerabilities to decide which ones are important and which ones they need to take action on. Secondly, a lot of the common distributions used in containers today were designed for stability. That means that they apply updates to packages very infrequently. Right? They tend to have a 3 to 5 year patch cycle where they freeze all of the versions of the upstream packages that they're using and then only backport fixes if they have important security changes. They don't update packages to pick up new features. This is great for a certain set of packages, things that build up the base of your system, stuff like the SSL libraries, curl, basic command line tools like cat and gzip. If you don't know or care which version is running, then the distribution kind of stable mindset is great. Unfortunately, there's kind of this bifurcation in this world where folks also run stuff like modern programming languages that update every 3 to 6 months, or language-specific versions of packages that might release updates weekly or bi-weekly. That forces you to make a choice on whether you want to use your language runtime from the distribution, where it's maintained and curated and built from source and has a guarantee around security patches, or get it directly from upstream. If you do that, then you're kind of breaking all the guarantees that the distribution provides you. And instead of installing stuff with the distribution-based package manager, you're getting it manually with shell scripts or curl and untarring stuff. That means a certain set of your packages are kind of curated and patched and maintained, and another set you're on your own for. And unless you're paying careful attention, it might not be clear which one is which. There's some side effects here too. When you're using those scanners and SCA tools I mentioned above, they have a very hard time detecting the packages that get installed outside of a distribution. So even though you might see hundreds of vulnerabilities sitting in your Node.js container, they might not have even found Node.js itself, or Golang, or some other popular packages and modern programming languages. All this combined means that container images that are designed for a typical distro experience tend to contain a lot more surface area than they need to. This can result in both increased attack surface, or they can result in a decrease in signal to noise ratio. Even if you're not using stuff like the shell or certain libraries that get installed during build time, they still show up in those scan results, and you still have to triage those vulnerabilities. This leads to a lot of problems. Finally, a lot of container images were designed to be easy to build and easy to maintain by using these convenient shell scripts and wrappers. But that means that we're kind of losing all of the provenance information. When we're building stuff with bash scripts, it's hard to keep track of exactly what source code was used to build a container image, where that came from, and if it was tampered with along the way. So we decided to try to tackle all of this by building a new Linux distribution called Wolfi, and that's where Wolfi comes in. The only real way to solve all these problems together, the transparency, the integrity, and the vulnerability management problems I talked about above, is to go down a level. By building a new Linux distribution from source, from scratch, optimized for containerized environments, we can try to address all of these together, because these problems are somewhat intertwined. So enter Wolfi. As mentioned above, Wolfi is the first community Linux undistribution built with default security measures for the software supply chain. Design it from the ground up to produce container images that meet these requirements, both the requirements for a modern supply chain and all of the compliance stuff coming down the pipeline. And we have an aim for 0 known vulnerabilities. By starting from scratch, installing only a known set of packages that are necessary at runtime for your application, and then having the ability to patch and curate the vulnerability feeds, we aim to keep Wolfi at 0 known vulnerabilities at head. So this allows us to solve the software supply chain problems from the outside in, or from the bottom up. Wolfi gives developers the secure base image they need to build their software on, and we've designed a modern set of tooling to scale to support organizations running massive environments and thousands or tens of thousands of packages and modern versions of programming languages. Because the tooling is so scalable, it allows you to provide the control you need to apply specific versions of packages or pin or support multiple versions of stuff like common programming languages, which is needed to support modern software development, which is needed to address modern software supply chain security threats. We're building all of these packages directly from source. That means we can fix vulnerabilities as they're reported or take patches from upstream directly as soon as they're around. This also means that we can apply customizations to those packages that improve the supply chain security posture of everything. One common example here is compiler flags. Modern compilers like GCC and Clang have added a lot of security features over the last several years, but these sometimes come with a cost, whether it's increased compile time, larger binaries, or slight decreases in runtime performance to do stuff like stack and heap protection. Because we're compiling everything ourselves, we can ensure that all of these flags are set, and that allows us to reduce the number of vulnerabilities that can actually affect your application at runtime. Some other examples here of how being able to tweak and manage the packages and apply patches ourselves can result in a better security posture is around SBOMs. Because we are building all of the compilers used in Wolfi ourselves too, we can instrument these compilers to provide accurate dependency tracking. So we know exactly which files were included in the binaries and can result in a more accurate SBOM where we don't have any false positives or false negatives. Secondly, Wolfi is designed to produce distro-list style container images. This means that they don't contain the full package manager, shell, and normal operating system environment you're used to. Because we have fine-grained dependency management, we know exactly which packages are needed both at build time and at runtime. And so we can provide the packages you need to build your application without bloating your final runtime container image. Some other approaches to this problem are stuff like multi-stage Docker builds, where you're responsible for doing this dependency resolution yourself, or a whole bunch of other tooling designed to run the application container image, see which files actually get accessed, and then strip them out at the end. These are great approaches to try to solve the problem working with existing distributions. But by going down a couple levels and building a distribution ourselves, we can address these problems without requiring any of those bolt-on solutions later. A couple times earlier on, I mentioned that Wolfi is a Linux undistribution. Well, that's a nice catchy buzzword. It's also somewhat accurate. The term Linux distribution typically refers to both the kernel package that's running on the bare metal or VM, as well as the user space packages. It's a little inaccurate to call Wolfi a Linux distribution because we're bundling everything except for Linux itself. That's why we're referring to Wolfi as a Linux undistro. We're providing only the user space packages today and in a componentized manner so that you only get the ones you need. You don't need to start with a full, heavy distribution style base. So thanks for listening to the HelpNet security video about Wolfi.